Well, good afternoon and welcome to MedTech Crossroads. We've got the famous Rick Routson in the actual seat there. You got to see him for just a minute. I am on the road this week, and it's actually, I'll just say hi to Rick there as long as I got him there. It's good to see you, Rick. Thanks for being both backup and your molding expertise going to come in as we talk to our guests today. So thanks for being here.
Oh, you're welcome, Gene.
And to our, yeah, we always appreciate you. I am going to talk to the audience here for a minute to say we've got a great show, which is episode 70. It's hard to believe we've been doing this 70 episodes long. It's Friday the 13th. Hopefully that just means it's a good day to you and nothing more. But today we're going to do COVID Connect, the COVID news, as well as our local news. And after that, we are continuing this month of August as a manufacturing month. So many folks, they say, I'm going to get my product manufactured. I've got a great idea. I'm ready to go. And there's always more to it than that. So we thought we could kill two birds with one stone and talk about, are you ready? As well as highlight some of Michigan's wonderful manufacturing sites. Today is going to be our friends at MedBio, and Drew Deslippe is going to be joining us in a few minutes. After that, we'll have time for Q&A. But right now, let's talk about the local news to remind you that in the month of September, the pitch party is coming back for Q3. We are looking forward to that. It's a $2,500 prize at the end of the quarter. If you know of companies that should be part of that, they can send a pitch deck to pitchparty@medtechcrossroads.org to be eligible for selection. They need to make sure they include problem statement, vision, value proposition, team, milestones, business model, competitors, and their ask. And the whole goal here is to talk about what our judges like and don't like about those startups and their presentations. Not really a competition because they won't all be in the same vertical. They won't all be working on exactly the same thing. Nevertheless, at the end, our judges will tip their hat to one of those startups, and they will award a prize funded by Into Being, but awarded by our independent judges. And I believe this next slide is those judges: our friend Andy Rader of Evergreen M&A Partners, Dr. Nikki Kennedy, she's a vascular surgeon, and much, much more. She's the founder of Arbor Hive. Jim Metzger, who's actually going to be on the show next week talking about Keystone Solutions Group, representing Michigan as a manufacturer. And Stacy Frankovich, the program manager at MedHealth. Those are our four judges, and we have enjoyed what they do greatly, greatly. We just chatted with all of them recently, saying, what's the future of the pitch party? And they are all raring to go into 2022. So we're looking forward to that. Let's talk about the COVID metrics and the vaccine distribution. As you know, things have been changing. COVID has been coming back. Delta has been really establishing itself. I want to start with this graphic that we said is going to be an important one to track. These are COVID-19 reported cases as a portion of the population, so per 100,000 people in the last 7 days in the state of Michigan. Now, what you're seeing is a complete mix of this bottom right chart. The percent of the population that's fully vaccinated up the left side, and the cases per 100,000 going across the horizontal axis. What you see is a massive distribution. There are some counties where a very small portion has been vaccinated, and nevertheless, the cases are low. Also where the very small portion has been vaccinated, but cases are high. You can also find counties where a large portion has been vaccinated and the cases are low, and where a large portion has been vaccinated and the cases are high. We continue to watch this to see if any trends emerge. Nevertheless, the new cases are trending upwards, as you can see, thankfully beneath the beginning of the pandemic, but we're also testing less right now. And so it's hard to make that comparison directly. It's nevertheless coming up. More importantly, the positivity rate is coming up. And so that means that COVID is making a resurgence. Thankfully, for the moment in the state of Michigan, the deaths are down. But as I think we know at this point, those lag by about 4 weeks. So we're just going to have to see where that goes. One would expect them to come up, but we do not know how high. Here's the community transmission in the state, county by county, the southern part of the state, largely in orange or substantial transmission. And of course, these colors, the ones that CDC has used to say if it's orange or red, they recommend indoor masking by both vaccinated and unvaccinated persons. Hospitalizations coming back up, still not to their old levels, but coming back up in the state of Michigan. And we will see again where that goes. A little bit of heartening news here. The curve is trending upwards in terms of vaccinations from its low near the beginning of July, nowhere near the peak in April, but it is trending back upward nationwide. And in terms of community transmission by county, the entire country is red. This is about what we showed you last week and continues in the same vein this week. So that is what we're seeing with respect to COVID. Not a lot more news than that. Some of the data, I have to say, is confusing coming out. We see reporting that still isn't aligning with raw data. We're just waiting to see where this goes. Certainly a lot of opinions out there. Do care for each other, do look out for each other, and keep an eye on that data and try to understand what this is actually saying. Well, with that, like we said before, August is manufacturing month. So many companies go out there and they say, I want to get my medical products made. I've got an idea. I must be ready to go. We've got lots of great manufacturers in the state of Michigan and all over this country, many with expertise in medical devices. And I'll tell you, the big question is, are you ready for manufacturing? At our company, at Into Being, we're very passionate about that question because a lot of what we do prepares people to be ready to approach manufacturers. But it's really important to hear from the manufacturers themselves. It's important to incorporate them into your process early in your company's life, to talk to them and understand what their constraints and their needs are. How do you know if you went too fast in the manufacturing? Well, sometimes very conscientious manufacturing vendors may even no quote if they're not able to make sense of what you're asking them for. Or maybe you make it into production, but you have to stop soon after you start. Or maybe design engineers are regularly being asked to go visit the shop floor to fix things that weren't finished in the design phase. Or maybe this product is costing more than you expected it to. These are indications that you might not have been ready to roll all the way into manufacturing. But nevertheless, today I am really thankful to welcome our friend Drew Deslippe from our friends over at MedBio. Drew is joining us on the show today to talk about MedBio and to talk about all things manufacturing. Drew, if you can make your audio and video live, we'll welcome you to MedTech Crossroads.
How you doing, Gene?
Doing well, Drew. Thanks for joining us today.
Yeah, thank you for having me. Appreciate it.
Well, you have seen the whole process, Drew, in your career. I got your little mini bio, and you literally started sweeping the floors in your early career at your first company. And then you've worked your way up from there to now you are the lead project engineering manager for MedBio's Clinton Township facility. Of course, a recent acquisition by MedBio. And when we said to the folks at MedBio, we want to talk design for manufacturability, they said, you got to talk to Drew. Drew needs to come on the show and talk all about that. So we said, well, that's a great idea. A number of months ago, we actually had Ron Williams, the founder of MedBio, on the show talking about his career. But today we're talking nuts and bolts. But before we get into MedBio, I'd like to hear from you. Tell us just a little bit about your career and tell us what your passion is.
Yeah, like I said, it's been a long road. Like you mentioned, pretty much started right from an early age. I was very technical, very hands-on right through high school. Came right out of high school and got right into the industry, while attending college at the same time. So, started at the bottom, which is something you don't see very often anymore, but, and kind of worked my way through every process along the ways of mold making, squaring up blocks, running a bridge pour, running a surface grinder, gun hole drilling, EDM, carbon cutting, machining. I never really stayed in one place very long. I was always interested for the next step, and always interested in on why we were doing things a certain step, which kind of kept me wanting to keep going. So, worked my way, for the first 10, 12 years through the manufacturing floor, and then, found myself falling into the program management slot. Spent roughly the last 8-10 years through program management, which kind of put me in a heavy design outfit to kind of follow things through and understand it. And then now, through the manufacturability, kind of understanding and seeing the projects run through the life of a program, you understand what good looks like and what failure looks like. You build it, you see it run, you see how long it lasts, you understand your failures and why it happened, which, makes us catch that earlier on in a quoting stage now in my career, so we can avoid a lot of those things and have those lessons learned.
That's so important to be able to see. Sometimes it's not just a checklist, right? Sometimes it's not just a recipe, but nevertheless, what kinds of things you're looking for, and you can kind of go, new project, let's explore here and see if we are actually catching these things. Well, yeah. This is good. I'd like you, Drew, to take us through a little bit about MedBio and MedBio's history. While you're bringing that presentation up, I'm also going to welcome Rick Routson to bring his video and audio on. Rick's from our team at Into Being. Has a lot of molding experience in his background, and he's a project manager as well as a company manager for Into Being. And after we get through the presentation about MedBio, we're going to have sort of an open conversation that you're going to lead, Drew, about design for manufacturability. If folks are listening to this, get your questions ready. If you're part of a company that has molded components, because this is invaluable, right? This is like your first meeting with a molder, to be able to talk about what matters. So as we get another 10, 15 minutes in here, we're going to have opportunity to talk about DFM and to answer some questions. But Drew, go ahead and take us through about MedBio. We'd love to know more about the company.
Sure. Like I said, you're already familiar, but MedBio it's a fast-growing company. Our company vision is to provide premier contract manufacturing services to the medical and biotechnology service industry. We leverage the latest technology and production equipment to maximize efficiency and quality. We achieve the highest levels of customer and employee satisfaction and provide stewardship within our community. This is just a little overview of our company and a lot of our services. So specializing in plastic injection molding, assembly, and packaging, project engineering and project management, the actual tool construction and the repair services that support our industry, all of the injection molding, certified ISO Class 8 and Class 7 clean rooms, and product assembly and packaging, certified ISO Class 7 clean rooms. Again, how do we make the difference? Roughly 30 years in the medical device industry. We experience in dedicated molding and clean room personnel. We have a scientific approach, which is taken when developing injection molding processes. The processes start at the time a mold is designed. It continues until the mold part is cured. It can be injected from the mold. Proper tool designs and instrumentation of the mold are key success to the subsequent molding. We're constantly looking into new technology every day and advancing our practices. And we have pure dedication to complete customer satisfaction. All of our facilities, so our big mothership facility is in Grand Rapids. As you know, we have 65,000 square foot on the east side, modular Class 7 clean room for implant molding. There's over 50 injection molding machines ranging from micro all the way up to 359 tons, 3 shifts of molding, 2 shifts of assembly. We have another facility in the Grand Rapids area on the west side And then in December, they opened a second world-class manufacturing facility, newly renovated 25,000 square feet, adjacent to MedBio's 65,000 square foot facility, with an additional 12,000 square foot of clean room space. Again, where I'm located, our Clinton Township facility, previously known as AIM Plastics. This facility, again, is a full-service manufacturer, allowing for additional manufacturing capacity need to support the growth and success of our customers. We have 32 injection molding machines, all the way down from 30 ton to 450 tons, and that's steadily growing as opportunities present themselves. We have an in-house tool shop, which we build all of our own tooling here in Clinton Township, that runs, there's two facilities side by side. We have 7,000 square feet of Class 7 clean room manufacturing in our Clinton Township facility. And then we range different types of tooling for rapid prototyping all the way up to high volume production tooling. Recently acquired Orchard Park, New York, which was previously known as Polymer Conversions. Again, a good outfit size company, 32 injection molding machines, up to 350 tons, clean room manufacturing, secondary assemblies, packaging. They have a silicone molding operation with the ISO 13485 in 2016 and ISO 9001 in 2015. Again, all of these companies kind of offer the same type outfit, and support one another and complement one another in the same fashion. These are just the different types of our capabilities within all of our facilities. Obviously, we deal with a lot of medical grade thermoplastics, implant grade thermoplastics. We run low, medium, high volume tooling, two-shot molding, micro molding. Now thanks to Orchard Park, we're doing silicone injection molding, thin walled parts, some hand load operations for prototyping, which we can further get into in the DFM discussions. And again, like all of our parts went through a full scientific injection molding process, which allows for repeatability and consistency in the quality. Again, this just kind of repeats some of the secondary operations that we can provide aside from molding. We have multi-component assemblies. We have custom design lean cell assemblies, fixturing and automation, pad printing and hot stamping, ultrasonic welding, laser welding, heat staking, laser marking, post molding, and adhesive solvent bonding. These are all things that complement the part in the assembly in the medical world. Again, this just kind of runs you through the DFM process, which we can get into more in depth, right from the design all the way to final production. Also within the MedBio footprint is Concept Molds, which was acquired, I think, roughly 8 years ago. They are a standalone tool shop that builds plastic injection molds, and there's 20,000 square feet of climate-controlled facility there, and that is in Grand Rapids as well. Or I'm sorry, Kalamazoo. The tooling, once again, so there's different types of tooling depending on what stage of the program you're in, whether it's in the development side, the DB build side, if you're looking for just a concept, or if you're looking for, SPI class tooling. So tooling could be built anywhere from 2 to 4 weeks for prototype stage, and could take as long as 8 to 12 weeks in a high volume production stage. This is the process for a prototype plus, which is kind of our speed to market niche. Basically, again, right from the tool design all the way through the manufacturing into the molding presses and right through a validation. This is just a lot of our quality and metrology equipment that we use through our validation process and a lot of our inspection methods. And again, some of MedBio's advantages, without all of our companies, we can run anywhere from low to high volume injection molding, insert molding and assembly. We build very small, intricate parts as well as large size parts, or we can do rapid turnaround prototyping all the way to complex tooling. Here are some of the industries served. So a big one is diagnostics and cell growth. You have cardiovascular, you have dental, drug delivery, general surgery, neurological surgery. You have orthopedics, pharmaceutical, respiratory, veterinary, and wound care. So that's just a really good overview of MedBio's footprint today and what that looks like and all the facilities under that footprint today.
That was great, Drew. I really appreciate that because oftentimes folks need to know sort of the big picture. Who is this that I'm talking to? What are they capable of? Of course, you guys have been around and grown over the years. Now, before we get into the DFM, this is one really basic thing to get out of the way. I know that when I started in the industry, I had no clue what this meant. And maybe some of our listeners don't too, so I'm going to ask it for them. When we refer to an injection molding machine by its tonnage, I think a lot of people go, oh, it's a really heavy machine. That's not what we're talking about here. Can you just give us a really basic overview of how that works and why we refer to these things in terms of tonnage?
Yeah, so you're right, because sometimes it takes a large tonnage machine. The tonnage is really what's used in an injection molding machine to cover the clamp of the pressure it takes to fill a part in its square surface. But aside from tonnage, there's different barrel sizes for the different shot volumes of your part. So a little tiny part with different actions could actually grow the footprint of your mold, which would require to go into a large tonnage machine. But then your injection units are also a different part of that. So a mold itself is not always, dictated by the tonnage, but it is just one factor that is used in the injection molding process.
Yeah, a lot of variables go in. I think sometimes folks don't even have a concept, if they haven't been exposed to this before, how much is actually going into this. These are very large machines holding these sides of a mold together with literally tons of force to hold back against the injection pressures that you have to use to pack out every part of this. Well, and it's this difference. It's this. I don't really understand the process. I don't really understand what it takes you to go through to make these parts. That's really the heart and soul of DFM, right? Designed for manufacturing. And I know you've got another presentation here you're going to walk us through, and we're going to sort of freeform it on some of these design for manufacturability topics for our listeners, especially if you're associated with a company that has molded components. This is really important. If you have questions, feel free to post them in the Q&A or raise your hand if you want to ask it live, because it's this difference between, oh yeah, somebody just takes this part and goes and makes it. But the actual details of that are life and death. They're make and break. They're the difference between this working and not working. They're the difference between it fitting and not fitting, costing what you think it should and not costing what you think it should. So Drew, if you would bring up, I know you've got a certain bullet list here of things that we're going to talk through in terms of what's important with respect to design for manufacturability. Let you have you kick us off on those.
Sure. And like you said, I was watching the beginning of your presentation, and you kind of brought up a few other points as well. So a lot of times where the story's lost too is, prototyping a part is one thing, but prototyping it so that it's designed for manufacturing is another thing. Especially as we get into the world of 3D printing, and it's more and more popular nowadays. Just because you can 3D print a part, doesn't mean you can manufacture it in a high volume world. So they all have their purposes, and they all have their spot. But that's really the key. it's making sure that you're prototyping something that you can repeat in a production manner, because it's no good unless you can really validate it.
And that whole concept of being able to repeat it, I think it's often missed, that the fact that you got something to happen once doesn't mean that the next time you do it, it's going to turn out the same way. And that's for any physical process. There's going to be variation. And these questions of like validation is, can you show that over time this thing's going to stay where you need it to be, to fit with the other parts, to work with the other parts, to do what it's supposed to do? Really important stuff. What would be a good way to start the DFM conversation? Do you want to bring up the outline that you have?
Sure, I can do that. There we go.
And even as you bring that up, I think one question that comes to mind, Drew, I know you work with a lot of clients who come to MedBio saying, I want to make this part or this subsystem or whatever it is. And what are some of the most common first conversations that you have? And maybe that's part of what this list is. I'll let you answer that how you want to, but just from an interpersonal standpoint, what are some of the most common things that you encounter when a client approaches you?
Well, again, so if we're speaking, my definition of DFM, so, the injection mold is one thing, but, a lot of times we're seeing too is, if you're looking at a validated part, you have to be able to measure it properly, and you have to be able to validate it and understand how you're going to certify it in a validated world for the medical industry. So, when we look at DFM, we don't just look at the tool. The tool build is only one piece of the pie. The print specifications and the validation is another thing to make sure you're not setting yourself up for failure. So I kind of broke it out into 3 different categories here. And if you can see my screen, this is just the first category when we're looking at the mold itself. And these seem so basic, but it's very surprising how often that these would trip you up. They would really reflect cost. They're really going to hold you up when you think you're full speed ahead, but really you're not. And one of the things that I always recommend with our customers is, I know it sounds like a sales pitch, but it's very important to pick a supplier as early as you can and work and build that developed relationship with them. There is a reason why we try and get involved as early as possible and we get ahead of the game. It's never good when you cut a PO and you think you're full speed ahead, and then you end up spending 2 or 3, 4 weeks trying to redevelop your part because there's dialogue conditions or stuff like that. So these are just some bullet point questions that you should be asking yourself when you're putting a part design together. And one of these things is, in a prototype world, you can do some manual operations to make a part that you necessarily wouldn't be able to do in a production world and validate. So one of the things are resin. Are we selecting the right choice of resin to produce the desired design and application? Some resins have high shrink rates, where you take something like Delrin that'll shrink, say, 18 to 20 thou per inch, and then you have, things like PC, polycarbonate, which will only shrink, 4 to 5 thou per inch. So if you have a really tight tolerance part, you have to understand your shrink rate of your resin. And maybe it is a high shrink rate, but maybe you should be factoring in some tuning or some tool grooming, because you may not hit that dimension right away. And it may impact cost or timing.
That one right there is a huge one. I just got to even pause you there, because I think this is something people often think to themselves, well, I haven't really fully optimized the material, right? I think I want ABS, but then they think, well, I'm going to cut this mold. There's some bad news lurking under the hood there. What happens if I want to go back and I want to completely change the material at that point? What's the upshot?
Well, and that's the problem, right? Because once you design a mold is designed to a shrink rate. So you're literally overcompensating the design of that mold to allow for the shrinkage of that plastic to be the size you want it to be through your design specifications and your final dimension. So if you pick polycarbonate at a 5 thou shrink rate and you try and switch to a higher shrink resin later on, you're scrapping core blocks and mechanisms, and again, just tearing through cost and tearing through your timeline milestone, which is not good. And then, another selection regarding resin is the shape of the part, right? So depending on the shape of the part, you should really be asking yourself, are we going to encounter any warp, any clamshelling in the part? What is the material behavior going to do, depending on this contour and shape? If it's a structurally sound part, if it's an appearance part. So all of those factors play into the resin, and you can really make or break something by choosing the wrong resin.
Drew, if I may interject and ask a question here. Mold flow analysis, as a tool for the design and manufacturing teams to help identify some of those issues. Can you just briefly talk about what that is and how that's helpful in achieving the kind of part that a designer may want to see and need?
Yeah, mold flow is a really big one. It's a step that is sometimes always, sometimes skipped. When you're doing a mold flow will allow you to select a resin, and you can simulate the flow of the resin and see, what that behavior might look like in a virtual manner, right? In a simulated manner. So you'll be able to see things like warp. You'll be able to see things like balance of fill. It'll tell you things. It'll give you suggested shrinks. It'll tell you what the behavior of your part should do. Again, mold flow is only as good as the person that's putting in the settings and operating it. It is a great design tool, and it should be used in parallel to the build process and the design process as well. So the final mold flow is actually just as important as the early stage mold flow as you're building the tool. Another question that always is asked, these are all the points that we kind of ask ourselves when we see a part. So obviously in an injection molding world, you have to ask yourself, you have to understand, have all dipole directions been identified on the part, which is going to establish acceptable parting line splits. So in an injection mold, you have a core half and you have a cavity half, and you have to have surfaces that are open to die draw in each direction. So if you have features that require a side pull and an A and a B half, those have to be identified to ensure that all the parting lines are pulled for all of those splits to take place. So die lock conditions are very common when we're looking at features, and that's kind of what's really going to dictate where your parting lines go on a mold and what that's going to look like.
For those who thought that their waffle maker on the waffle shape was just some kind of an arbitrary shape, now you know the reason that those are these drafted little squares. There's a reason for that, because it comes apart easy, and that's what you're talking about here.
That's right. That is correct. So the third one, again, is die lock conditions. It's nice to look at your part and understand if you were trying to pull that apart and look at each different way, you have to ask yourself, if I was to make a mold out of this, which directions would I be able to pull that, and am I locked in any way? So we get into mold flow. I know, Rick, you asked this. Gating. Gating's always a big one. Depending on the complexity of your part, the shape, where the features are, you have to understand that you have an acceptable area to gate your part, and what type of gate you need to use depending on the application. And some resins also might dictate the style of gate that you have to use, which is also going to limit you.
That's a little thought about parts there, because you design this part, it looks beautiful, everything is great, and then of course the plastic has to make it into that shape somehow. So you have to pick where is that little defect usually. I mean, it's going to look like something. You're going to notice it. Where is that going to be on the part? That can get overlooked in the design process.
Yeah, that's correct. And there's so many different ways to gate a part. Resin dictates it a lot of times. Complexity of the tooling dictates it a lot of times. Nobody wants to see a gate vestige on a show surface, but you have to go somewhere, right? So it's best that you just ask yourself these questions in the design phase and understand it. This is always a big one when we receive a product. It looks nice, it looks great, but we're always left on an island trying to ask ourselves, how are we going to gate this? And how are we going to pitch this to the customer and get them to understand we need a gate here and this is why. So there's always two ways to look at gating something. You either gate from an end-to-end fashion, or you want to gate something so that you have a balanced fill and things are filling in a symmetrical pattern, and you're not filling one side versus the other, which is going to cause processing issues. So, and when this resin is molten, it likes to fill from thick to thin surfaces. So if you have thin wall stock conditions, it's obviously not ideal to start your gate in a thinner area rather than a thicker area, because thinner areas happen to freeze off and set up faster. So you're going to want to understand all of those parameters when choosing your gating selection. Next question, draft. Draft is a big one. So in the injection molding world, draft is a mold's best friend. Every which direction your part is pulling, you have to allow yourself sufficient draft to be able to have part release. Core sides, you can get away with a lot less draft, as the B side is relying on your ejection to push it off the part. But your cavity side is not so friendly. You have to make sure that part's going to want to stick on the core, and you have enough draft that's going to allow the part to come off the cavity free, and it's not going to create any drag marks, any burrs, any scoring, and it's something that's going to have to withstand production. A lot of times, a brand new tool with very low draft can work, but when you get, say, 10,000 shots in and steel nests in, it becomes a maintenance issue when you're having to deburr parting lines. You start picking up drag marks, and it really dictates the robustness of a mold during production.
True, and also when you have parts that you want to have be handheld parts and you want to put a nice texture on them, that only increases the need for larger draft that you may not think of in terms of a smooth part, which will need less draft.
Yeah, that's a very good point. So your draft is calculated depending on its surface finish, and where if you have like a MedTech 11020 draft or texture, you're going to need more draft angle, or you're going to start seeing scuffing on your texture, or it's going to want to stick, because texture is it's like a sandblast, right? It's like elastic. It's going to want to hold that part on. So draft is really dictated depending on the depth of the wall and the surface finish allowed. And then there's two factors when you look at draft. So you have a part that's shrinking during the injection molding process. So there's two things to look at. You're either going to shrink on steel or you're going to shrink away from steel. So if your plastic is sitting in a belly, imagine on the cavity side, it's going to shrink away from it, but on the core side, it's going to shrink on it. And that also plays a big factor in your draft analysis and understanding that if you're shrinking on or shrinking off of steel.
It's kind of funny because if you just ask somebody, I'm going to cut a big hole in a chunk of metal and I'm going to shoot a bunch of plastic into it, would you think it would come out again? And the answer is no, of course not. It would get all jammed up inside and you'd never get it out again. And yet that's what we're asking you guys to do when we say, can you mold a part? We're asking you to cut a really complex hole in a couple of chunks of metal and get the thing to come out without barely pulling at all, just like pulling apart so gracefully. It's really more like building a robot than it is like building a what you think of as just quote unquote a mold.
Yeah, I mean, we really try and stay to strict standards. There are exceptions, and you know, we're always willing to take some risks, but they have to be calculated risks and they have to be followed up with a backup plan. Nobody ever wants to hear no when they have a part design that they're proud of, and you have to tell them no, that it's not going to work. You know, one of the things I'm always a big fan of trying something new, as I always like to learn, and you know, a lot of my success were based on failures, right? Everything I know today is because I screwed it up at least once. So, you know, we just have to understand its risk analysis to the product and what the backup plan is. If you're going against the standards, just make sure you have a backup plan and you understand it's not standard to do what you're doing, and you have a second out.
Gene, we actually have
That's great. We do have a question here, which I'll just throw in right at this point since we're in dialogue here. From Michael, do you use 3D printing to help design instead of building a mold first and then making changes? I understand flow, shrink rates, et cetera, all play into that. Does 3D printing play a role in your process of thinking about what you're going to build for a mold?
It's never a bad. Again, it really depends on the application, but I will say this, and I'm guilty to it. You know, we stare at these big computer screens all the time, and we blow up these parts, and they look this big through the whole design phase, and then you get all the way to an injection molding part, and then you got this little tiny part in your hand, and then now you start to think and things, you understand things a little bit better. So, you know, for 3D printing, it is really nice to actually put a piece of plastic in your hand to understand, you know, a clip and how much a part's going to flex and how strong it's going to be. A 3D printed part doesn't have compressed plastic like injection molded does, but it's never a bad opportunity to, if you can put a 3D printed part in your hand, it's never a bad thing to do.
Good question, Mike. Thanks for that.
Just one more point on that, though. Just because you can 3D print a part does not mean you can injection mold it either. They have their differences and their applications, and we just have to realize that. It's nice to put that part in your hand, but it doesn't mean it's ready for injection molding all the time. I'll just keep going down the list here unless you stop me. One of the other ones, so you have your B side of the part at all times. Another good question you have to ask yourself is, when this mold opens, we're going to have to eject this part off the steel. And we need areas to be able to eject the part from. So we have to be able to present locations, which are going to be impressions that we're going to push on that part. So another question you want to ask yourself when you're looking at this, you know, gating is a big factor, and how are we going to get that part ejected off the steel? So that's a big factor.
A lot of times you may have looked at the inside of a part that's nearby you and thought, what are those shapes on the inside? It doesn't make sense. Why would those end up there? I just had a battery door sitting here, and of course you can see these little circles on the inside. That's what Drew's talking about in terms of the ejectors. Here it doesn't hurt. I'm on the inside of the part. My outside is nice and, oops, I just dropped it. My outside is nice and smooth. It looks great. You got some writing on the back there. But on the inside, somebody had to make the decision. Yeah, we can like literally damage the back of the part with these little circles. Not damage,
Yeah.
but create witness lines there. And it's okay for that to be inside of the part, but that's where it got pushed off, right?
That's right. That is correct. And we have to be able to identify those areas where allowed and where not to be allowed. So when you have deep ribs like you showed, you know, and you have molds, you're packing in plastic at 7 1,000 PSI, you're packing it in really tight. So you have to be able to push on those ribs and have good, robust spots to be able to eject the part. Another really good question we should ask ourselves, this is a really good design practice. When you're looking at wall stock sections on your part, to have a common wall stock across the part to ensure consistent shrink rate and minimize warp. So it's always good that your part is shrinking in the its same fashion. If you have different thicknesses of parts all over the place, it's going to want to shrink at different rates, and you might start seeing clamshelling on your part. You might start seeing warp. If you have a really flat part that's supposed to sit level, you might see certain areas start to lip up. So really understand your wall stock on your part and really try and keep it as consistent as possible. And then the last point here, obviously, sink marks are very, very common on a part, and you have to be able to identify those in your design. And you have to understand, one of the main factors is a rib to wall stock ratio. So like the part you just had in your hand, Gene, you have ribs on the B side of your part, and then you have your main panel. If you took that in a T fashion, and then you had a circle ball around that section, if your B side ribs are not thinner than your common wall stock, it's going to want to pull plastic from the A side, and it's going to want to create a dimple in your part. So ideally, if you had 1 millimeter on your cavity side, those ribs that you see on the B side, you do not want them to be the same size wall stock. They have to be roughly 33, 35% thinner than your common wall stock.
So Drew, you're saying these little ribs back here that make perfect sense for holding the batteries in and everything else, they are a little bit thinner than the sidewalls of this part. And what you're saying is, if they did this one right and I flip this over, we ought not to see a divot coming down the backside of this. But if they somehow didn't do their job, we would see almost like a dent coming down the backside. Is that a fair way to say it?
That is correct.
Okay, so we're gonna do the big reveal. We're gonna do the big reveal here and see whether this particular manufacturer of this particular lawn and garden part did their jobs. We're gonna flip it over, and it looks not too bad. Not too bad. But that's to be expected because, like you said, this is already a thinner piece right here than it is of the body.
That is correct. And sometimes think's acceptable. If you have a structural part and you need that thickness, it's okay. But, one of these questions you should be asking yourself is, if it's a show surface, it's something someone's going to put in their hands, it's not going to look good. It's going to impact warp. It's going to impact your curing time, your mold, what your cycle time looks like. So you should just try and really standardize that rib to wall stock ratio. And it's resin dependent, but it's, 25 to 35% is your factor.
Yeah, I think that can be one of the common problems too with 3D printed parts, is that all that stuff gets lost and not thought about. Is that, a 3D printed part, except for the surface, I mean, it looks perfect. It doesn't, you can have really thick sections in it. You're not going to get sink on those. And the person designing it, at least at the higher level, that may not know the intricacies of design plastic, may get false impressions of what their part is going to look like. And then the part comes to you guys and you notice these things and say, whoa, this could potentially be a problem if you can't have a big divot here or sink here. And so that's where the back and forth then, and what you feed back to the customer is, well, if we want it to look like a nice smooth surface, you're going to have to do these types of things to the design.
Again, all of these are very basic design practices, but to the 3D printing point, the more 3D printing has been introduced, I'm seeing that a lot of these are being left on the table because it's not thought about in that fashion. Everybody puts a 3D printed part in their hand and they think they're ready to go, but it's a whole different process. If you were mass producing 3D printed parts, that's completely okay. But if you're prototyping in a 3D printed fashion and then think you're going to go right into production on an injection molded world, you might want to look at all of these questions and really run through them and make sure that they apply to the design that you 3D printed.
Good to recognize those differences. I just want to remind our audience, if you have any questions like Mike did a minute ago, feel free to put them in. We are running low on time, so I want to get any questions in that you may have. If you have a specific one. I know you've got at least about 2 more topics here. We've got about 5 minutes left in the show. I see print specifications and IQ, OQ, PQ. I would love it if we can get about 2 minutes on each of those, because I think those are both really important just to know that they exist as things that companies have to think about in their development process.
Yeah, they really do exist. And, I really try and look at these questions earlier on stage so that, you don't have a mold built and you realize that you built something that you can't measure. So I'll try and be a little quicker through this, but some of the questions we really try and ask ourselves, when we look at a print that comes to a model, you have to make sure that you can grab this part and you can measure it. You have to understand how you're going to measure this part. Are you going to destroy the part to try and measure it? Because that's not going to work in a validated stage. Do you have good attributes that are going to monitor the process so you can control the stability of the part? Does your print call out, gate vestiges that are allowed and what that specification looks like for your design? Are all dimensions clearly identified in the exact areas that need to be measured? And then one of the big things we see in the manufacturing world is a lot of one-sided tolerancing. The one thing I will mention is one-sided tolerancing is okay in a measurement method, but when you have 3D data and you're trying to tool it, you have to understand that a mold should always be allowed to take 25% of the print tolerance. And if you're on a one-sided tolerance and your CAD model is designed to that one side, you're already not going to meet that dimension more times than not. So you're already set up to fail unless your design is going to be split. So I would advise if the spec is a one-sided tolerance on your print, at least make your 3D data be in the center of that tolerance so you have a better success of nailing it the first time.
It's a really important point. I don't think most people realize that the tolerance, you could apply a tolerance to any particular geometry that you have there. And so what you're saying is people are going to this point where they're saying, well, it can't be any, let's say, smaller than this, but it can be bigger, and they're biasing that tolerance all to one side. But if you don't target the middle of the range roughly with your actual data of the drawing or of the part that you made, we might not be succeeding here.
That is correct, yeah. So that's a big one. We see that mistake a lot of times. And it's hard to catch, too, unless you're really comparing the two. A lot of times prints aren't looked at until the part's in your hand. Unless the mold maker manually takes that print and compares it to the data he's cutting to, you sometimes won't catch that, which could cost money and time.
Great. Yeah, and I think it's important just for folks to know that prints do exist, like the necessity of telling the developer of the mold, okay, this is what the part actually has to be capable of. Here's what it has to meet. That's not always contained in the 3D geometry by itself, right? So these usually are accompanied by prints that specify that kind of information. If you're not aware, now you are.
Yeah, in more days, we're seeing a lot of auto dimensioning. You have software now that'll auto dimension stuff, and, it's really setting you up for failure. You should really try and avoid auto dimensioning. It's okay to be, to get it done in a quicker manner, but then where you can open up tolerances, there is an injection molded tolerancing standard as well as a machining standard. So if you're putting tight tolerances on things that don't require a tight tolerance, you just may end up costing yourselves time wasted as well as money spent. So, the more you can open up your tolerances, the closer you are going to be to a quicker success.
Well, in this last minute that we have, Drew, tell us more about IQ, OQ, PQ. I want our audience to be aware that this exists and that it's something that you guys, as a part of your practice, do.
Yeah, IQ, OQ, PQ is a general term for the medical validation device. So one of the biggest things that I see that's a big pet peeve of mine is going into validation too quick and making sure that your tool is robust. You have a developed process, and you're really ready to go. So a lot of times we see people going into validation when there's open tuning still left on a part. You should really ask yourselves, have I performed a one-piece dimension that at least has a clean dimensional product? Are there any open tooling issues that I'm going to be encountering during the validation process? Has my mold ran for some time and really been debugged to make sure that it's robust enough to go into validation? And then really with today's world and the capacity strengths and our resin strains, you should really be trying to set yourself up for opportunities to validate similar presses and possible similar resins. It's never a good thing to really constrain yourself to one thing in today's world. That's really something we're seeing now a lot more.
Well, this is such helpful stuff, Drew. And we're at the top of the hour and now, so we'll have to close it down. But I can't thank you enough for being part of this. I hope that this has opened folks' eyes. If you thought that this was just a black box, you toss it over the wall and you get perfect parts back. There's a big process here, and with a partner like MedBio, it's hopeful you guys can actually work through that. And these are some of the kind of things, also the kinds of things that designers can be thinking about beforehand. I know in our business we think about these kinds of things all the time, but it's invaluable to have that manufacturing partner in the process early on to have these kinds of discussions about your specific part, because that's make or break to the project often. So with that, Drew, I want to just thank you for being here. If anyone has any questions, I'm sure we can get you guys in touch. Rick, thank you for being here. I love your questions and your insights today as well. And Drew, any last comments for folks?
Yeah, Gene, thanks for having me. It's been fun. I will say this, like I said, it's not just a sales pitch. We encourage the engineers and the designers to get in touch with us sooner than later. We have a full crew. We're always happy to get involved in the early DFM stage and support your team as needed. So don't hesitate to get us in as early as possible.
Wonderful. Well, and it's do you have a website or an email that you can throw out there for folks?
We do. I'll just share the screen one last time. This is our main website, www.medbioinc.com. This will reach every one of our facilities, so check us out and don't hesitate to pick up the phone. We're happy to support.
Wonderful. Well, Drew, thank you for being with us. Rick, thanks again for being here. Thank you in the audience all for being there with us today. We really appreciate you. August still continues Manufacturing Month, and I believe next week we're talking with the folks over at Keystone about their processes. So thank you for being with us today on MedTech Crossroads. We'll talk to y'all soon.
Great to be on.